This is the last part of section 4.3. Keeping in mind that we are getting ready for a test next week. We have moved the test to Thursday. Originally I told you guys it would be Wednesday. All right, so please make a note of that we are moving the test to Thursday next week. Also keep in mind that it will be part of it with a calculator, part of it without. Okay, so if I'm asking you, for example, to find the sine of 15, you're going to use your calculator. But if I say what's the sine of 30, you should know that, right? Our 30, 60, 90, 45, 45, 90 special triangles and unit circle help us find all of those. So for Monday, we have the digital learning day. Okay, you will be getting 2 worksheets today, 2 review packets. They are split. One is with a calculator, one is without. Okay, now when I say you can use your calculator, that doesn't mean you don't have to show work. Okay, you're still showing me what it is you're setting up. It's just that we're going to let you use the calculator to get the final answer. Does that make sense? Okay. So those of you who have to leave early, make sure you grab those worksheets before you go. All right, so the last little piece, we're talking about the period of our different trig functions. And we mentioned it a little bit yesterday in that exploration we did. We said if we know the sine of an angle and we spin around a full rotation, so we land back in the same spot, the sine's going to still be the same, right? So when we talk about those coterminal angles, full rotations, for sine and cosine, we get the same values. Sine and cosine, for sine and cosine, our functions have a period of 2 pi. All right, that is going to be really important to know, especially when we get to graphing them in the next half of this chapter. All right, for tangent, our functions have a period of 1 pi. Do you guys remember talking about that yesterday? If we go just 180 degrees or half of a rotation, we get to the opposite x and y coordinates, but when we divide for tangent, it comes out to be the same. All right, so a function, it says y equals f of t is periodic if there is a positive number c such that f of t plus c is the same as f of t. The smallest such number is called the period. So what we're saying is for sine and cosine, t plus 2 pi, right, is going to give you the same value as t. Okay? For tangent, it would be t plus pi. This behavior also helps us train ourselves when we cannot or should not use a calculator. So we can find a lot of things without actually resorting to that calculator. So we have 3 examples here. It says find each of the following numbers without a calculator. The first one says, what is the sine of 57,801 halves pi? Okay, so the first thing I want you to do is take 57,801 and divide by 2. Let's think of what that is as a decimal instead of a fraction. All right, you could use a calculator for that. You just can't type in the trig functions. Okay, so what is 57,801 divided by 2? All right, so we've divided. We get the sine of, you said 28,900 and a half. Okay, now when you think about that, that's a lot of extra rotations, right? 1 rotation is the same as 2 pi. So let's divide that by 2 pi. This is divisible by 2 pi, right? Or by 2. We still have the pi on the end. So would that 28,900 represent complete rotations? Yes? So that just means we're going to spin a lot of times, but we're still going to end up with the half pi as the leftover little piece. Does that make sense? So the sine of this whole thing is really the same as the sine of 1/2 pi. Well, where's 1/2 pi? It's the same as our 90-degree mark, right? So if we think about our unit circle, we've gone from here to here. What are the coordinates if I'm on the positive y-axis? 0, 1. And which of those is my sine value? Sine is y over r, but in this case r is 1. Okay. So we really did all of that without needing the calculator to help us. It was one of our known angles. Okay. For this next one, we are looking for the cosine of 288.45 pi, and we want to subtract the cosine of 280.45 pi. How much bigger is the first angle than the second? An extra 8 pi, yes? So could I write this first piece as the cosine of 280.45 pi plus an extra 8 pi? Is that equivalent? Okay. Well, the cosine of 8 pi, that part of it, that's complete rotations, right? That's just 4 extra spins. So will the cosine of 280.45 pi be any different than the cosine of 288.45 pi? Okay, this is 4 rotations. So I'm going to land in the same spot, right? I've got a coterminal angle. So this simplifies down to just the cosine of 280.45 pi. And if I subtract the exact same thing, what am I going to get? Okay. What did we say the period was for tangent? Tangent is just 1 pi. So picture going to pi over 4 on our unit circle. Where is that? 1/4 of the top half, right? So we're at basically 45 degrees. Okay? So I've gone to that angle, and now I want to do this. I want to go in the negative direction a ton of times. Yes? Now, that's not an even number, but that's okay, because I just need 1 pi to land and get the same tangent value. Okay? So if I spin 1 pi, I'm down here. Spin another pi, I'm up here, right? And I'm just going to keep doing this. So it really doesn't matter if I land back here or I land down here, right? My tangent's going to be the same. So this doesn't matter. The whole thing is going to be equivalent to the tangent of pi over 4. So let's think about pi over 4. That's a 45-90 triangle. Yes? What are my sides in a 45-90 triangle? Okay. So tangent would be what? 1 over 1. Okay. Questions about that? So you can use that idea of period to say these are really going to get me equivalent answers. All right. It says at this point we should be able to use reference triangles and quadrantal angles to evaluate the trig functions for all integer multiples of 30 and 45 and their radian counterpart. Now what that means is we've talked about our 30-60-90 triangles and our 45-45-90 triangles, but we can expand that to go all the way around the unit circle. There's a picture drawn here for you. However, you do not want to rely on that. This is something you want to have memorized. Now it looks like it's really complicated and it seems like it's going to take you a long time to get it memorized, but there is a pattern to it, and if you focus on that pattern, it's really easy to recreate it. Okay? You just have to know one. What's the one I told you guys to memorize? Sine of 30 or pi over 6 is 1/2. If you know that, you can build the whole thing. Okay? So, flip that page. Do you have a blank unit circle? Okay. All right, so we're going to look at how we would start creating this unit circle. Now you guys have some measurements on yours that I don't have on my sheet up here. I want to explain how we're getting those measurements. let's just take the top half for now. Okay, this is going to be 0 degrees. We're going to go around in degrees first. Okay. Next mark would be what? 30 degrees. And try to do this without looking at it in your notes packet. I know. That's what I'm saying. Let's answer the questions up here without looking at your sheet, because yours are already marked. Next would be what? 45, and then 60. This would be 90. Okay. Now, if we think of those same intervals, what would this space be from here to our next? It's a 30-degree space. Yes? So this would be 120. Now, skip one. This one down here would be what? 150, right? Because we're counting in 30s. Sorry, I'm putting it in the wrong spot here. What would the middle mark be? 135, right? Halfway between those, if we're starting to count in 45s now. Okay. Down here, 180. Okay. Now we can keep going. Some people like to just go through all the 30s first and then fill in the 45s later, or do the reverse order. It doesn't matter. Some people just get them memorized along the way. All right? Doesn't matter to me. Our next chunk is 30 degrees more. So 210. This would be how many degrees more? Just 15 more for this one. So we're at 225. Another 15 puts us at 240, 270, 300, 315, 330, and 360. Yes? So can you do that without needing any help? Yes. Okay, now let's go through with pi, or radians. Okay. So first one we say is just 0 radians. Okay. If we get all the way around, we're back to 2 pi radians. Okay. Opposite side, we are at 1 pi. Yes? Straight up, we are at half pi, right? Or pi over 2. Straight down, we would be at 3 halves. Okay, let's break it into pieces now. Taking that top half, if we cut it at the 30-degree marks, we're splitting it into what kind of fractions? Sixths? Okay, so this would be 1/6. Okay, we're going to skip the 45s for a minute. 1/6. Next would be 2/6, or 1/3. Right, 60 is pi over 3. Okay, this would be 3/6 straight up, which is pi over 2. Next would be 4/6, which would be reduced to 2 pi over 3. Okay, skip our 45 ones. We're at 4/6. Now we're at 5/6. And then pi is 6/6. Yes? So you're basically just going to go around and count in sixths. Reduce them when you can. So 210 is the same as 7/6. 240 would be 8/6, or 4/3. Okay. 9/6 is 3 halves. 10/6 would be 5/3. Okay. 11/6. And then 2 pi is 12/6. Does that make sense? So we're just going around counting in sixths. For the 45s, we're counting in what fraction? Fourths, right? We're taking that top half and splitting it into 4 parts. So our first one is going to be pi over 4. Straight up is 2/4, right? Over here, 3/4. 4/4 would be 1 pi. Down here, we're at 5/4. Straight down 6/4. Over here, 7/4. Okay? So if I ask you to give me degrees and radians, can we do that? Could you recreate it on a blank unit circle? Okay. The part that is going to require some memorizing is the coordinates at each of those spots. But I want you to think in terms of your reference triangles, okay, your 30, 60, 90 triangles and your 45, 45, 90 triangles. So our first one here, if we think about this triangle, we said this was 30 degrees here. Okay, how do we label the sides? 1 here, root 3 on the bottom, and 2, right? So the coordinates are always cosine and then sine, right? Cosine is x, sine is y. Our r value is 1 because we have a unit circle, radius 1. So I just need my cosine and sine values. What's the cosine of 30 degrees? Root 3 over 2. Okay, so my first coordinate here is root 3 over 2. What's the sine? Okay, now, what would change if we move up to a 60 degree? In other words, if I use the same picture I've drawn here, this is 60 degrees here, right? So I could draw my 60 degree one here, okay, but it's really the same triangle. Okay, so cosine of 60 is a half, and sine of 60 is the root 3 over 2. Okay, so notice 30 and 60, they're just flip-flopped, right? Okay, how about our 45, 45? Can we visualize that without me drawing it in? 45, 45, our two legs are 1, our hypotenuse is root 2. So sine would be 1 over root 2, and cosine would be 1 over root 2. Rationalize, that is, okay, so for 45s, my numbers are root 2 over 2s. Okay? All right. We're almost out of time, but I need you guys to focus for just another minute before pep band kids leave. We can take those same triangles and make reference triangles in the other three quadrants, right? And we talked about using the reference angle gets us the same trig function. So I can take all of this and flip it to other quadrants, and all I have to really think about is, do my x and y values change to negative or not? So for example, if I take 30 degrees and I flip it to quadrant 2, okay, a 30-degree reference angle, I'm looking at that triangle, right? The only thing that changes is that now x is negative. So my coordinates right here are going to be the same straight across, but I'm going to make x negative. So I'm going to have negative root 3 over 2 and 1/2. Does that make sense? So all of these are just going to flip straight across, but the x is going to be negative. Okay? And then you can continue that flipping to the bottom quadrants. Okay? The other thing to remember, I said if you memorize one thing, I memorized the sine of 30 is 1/2. Your numbers go in a pattern. Numerators 1, 2, 3. Yes? Other ones go backwards. 1, 2, 3. So if you know one of them, you can do all the other ones. Does that make sense? Okay, I'm going to pause this for just a sec and get those worksheets handed out, and then we'll continue with those who are still here. All right, let's continue on. The only thing that we haven't labeled yet is 90 degrees and 180. What happens at 90 degrees for our coordinates? Coordinates up here? 0, 1. And at 180, we're at negative 1, 0. Okay. So let's go ahead. 270 would be 0, negative 1. And back at 0 degrees, or 2 pi, 1, 0. Okay. Using that same idea, we can take our 30-degree reference angle here and move it down to here. Yes? So if I know the coordinates right here at 150, and I go to move them down here to 210, what changes? I'm reflecting it over the x-axis, right? So my y value changes. So now both are negative? Okay. So we've got root 3 over 2 and 1/2, both negative. Next one down, our 45s are the easy ones because the coordinates match, right? Root 2 over 2, but both negative. Okay. Down here at 240 degrees, we just reverse the coordinates that we had at 210. Yes? Again, watching that pattern. We have 3 here, 2 here. This would have to be 1. And then 3, 2, 1. Okay. Last quadrant. You can either reflect quadrant 3 over the y-axis, or you can go back to the main quadrant, quadrant 1, and flip things down. Doesn't matter. Okay, so if I take 30 degrees and flip it down to negative 30 degrees, which would be 330 degrees, my coordinate, what changes? Which one? The y. So now I'm going to have root 3 over 2 is positive, my y coordinate is negative. Okay? Root 2 over 2 and negative root 2 over 2. Last one, 1/2, negative root 3 over 2. Okay? So, could I ask you to tell me the sine of 300 degrees? What's the sine of 300 degrees? Sine is which coordinate? Sine would be negative root 3 over 2, right? Sine is y? 300. Okay? If I said we're using 5 pi over 4, 5 pi over 4, everybody find it? Okay? And if I want the tangent, how would I find the tangent of 5 pi over 4? At your 45 reference angles, right? Tangent's 1 or possibly negative 1, depending on which quadrant you're in. So in this quadrant, tangent would be positive 1? Okay. Do you have on the back side of that? Yeah. Let's just do the first couple. Okay? All right. So, the first one asks for the sine of 0. What would you tell me? Sine of 0? Sine of 0 is 0, right? You mix those up all the time. Sine is y, right? Cosine first, sine second, alphabetical. Okay? So, sine of 0 is 0, right? Your next one says, what is the sine of pi over 4? Pi over 4, sine would be root 2 over 2. All right? I want the tangent, now careful here, the tangent of negative 13 pi over 6. All right? We got to think about that one for a minute. Negative 13 sixths. Where do I go? I'm starting here. I go clockwise, right? 13 sixths is 12 sixths plus an extra 1 sixth, right? 12 sixths is all the way around, plus an extra 1 sixth. So I'm down here at 11 sixths pi, right? That's where I land. And I want the tangent of that. So tangent is sine over cosine. All right, let me. Tangent of negative 13 sixths pi. We said that is a full rotation plus an extra 1 sixth, right? So we are down here equivalent to 11 pi over 6. And our coordinates, we said, at 11 pi over 6 are root 3 over 2 and negative 1/2. Okay? So if I want the tangent, I want the sine over the cosine, y over x. All right. So in this case, my sine is negative 1/2. I'm dividing by root 3 over 2. What happens to those 2's? Those 2's drop out, right? because we multiply by reciprocal, the 2's drop out. This becomes negative 1 over root 3. Rationalized would be what? Okay. Does that make sense? Sort of? You'll get started on that process? All right, so we'll stop there. We'll finish that sheet on Tuesday when you guys are back. And refresh your memory on all of the unit circle stuff. All right, so your assignment for tonight, your assignment is the last part of 4.3. For Monday, on our digital learning day, you have the extra worksheets, the review worksheets to get ready for our test. Okay?